My dear students, welcome back to our channel. In this video, I will be explaining the BCA third semester subject Java Programming as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 3 first important short question is: what is a thread in Java? A thread in Java is the smallest unit of execution within a program. Think of a program as a house and threads as workers who can do different tasks at the same time. Threads allow a program to perform multiple tasks simultaneously, which makes the program faster and efficient. For example, in a music app, one thread can play music while another displays lyrics. Key points: every Java program has at least one thread called the main thread. Threads run independently, but can share resources. Threads are part of multithreading, which is important for concurrent execution. Example: class myThread extends thread. Public void run. System.out.println, thread is running. Public class test thread. Public static void main, string, args. myThread t is equal to new myThread. T.start, starts the thread. Output: thread is running. Memory trick. Program is equal to house, threads is equal to workers doing multiple jobs at the same time. Next important short question is: 2. How to create threads in Java? In Java, you can create a thread in two ways. 1. By extending the thread class. Create a class that extends thread. Override the run method with the code you want the thread to execute. Create an object of your class and call start to run the thread. Class myThread extends thread. Public void run. System.out.println, thread is running. Public class test thread. Public static void main, string, args. myThread t is equal to new myThread. T.start, starts the thread. 2. By implementing runnable interface. Create a class that implements runnable. Implement run method. Pass the object to a thread and call start. Class myRunnable implements runnable. Public void run. System.out.println, runnable thread running. Public class test runnable. Public static void main, string, args. Thread t is equal to new thread, new myRunnable. T.start. Memory trick. Thread is equal to worker. Start it by start. 2 ways: extend thread or implement runnable. Next important short question is: 3. Synchronized keyword in Java. In Java, multiple threads can access the same resource or method at the same time. This can cause data inconsistency. The synchronized keyword is used to control access so that only one thread can execute a method or block at a time. It ensures thread safety and prevents problems like race conditions. Syntax: synchronized void method name. Code that only one thread can access at a time. Example: class counter. int count is equal to 0. Public synchronized void increment. Count plus plus. System.out.println, count plus count. Public class test sync. Public static void main, string, args. Counter c is equal to new counter. Thread t1 is equal to new thread, c dot increment. Thread t2 is equal to new thread, c dot increment. t1 dot start. t2 dot start. Output: thread safe. Count 1. Count 2. Memory trick. Synchronized is equal to lock the method. Only one thread can enter at a time. Think of it like a single key to a shared room. Only one worker can enter at once. Next important short question is 4. What is the use of finally block in exception handling? Use of finally block in Java. In Java, exception handling uses try and catch to handle errors. Sometimes, we want to execute certain code no matter what happens, whether an exception occurs or not. This is where the finally block comes in. Code inside the finally block always executes after try and catch. It is commonly used to release resources like files, database connections, or network sockets. Syntax: try. Code that may throw exception. Catch exception E. Handle exception. Finally, code that always runs. Example: try. int data is equal to 10 may throw exception. Catch arithmetic exception E. System.out.println cannot divide by 0. Finally, system.out.println, this block always executes. Output: cannot divide by 0. This block always executes. Memory trick: finally is equal to cleanup crew. Always runs, even if exception occurs. Think of it like turning off the lights after leaving a room, no matter what happened inside. Next important short question is 5. What is deadlock? What is deadlock in Java? A deadlock occurs in Java when two or more threads are blocked forever, each waiting for the other to release a resource. It is like a traffic jam at a crossroads, where no car can move because each one is waiting for the other to go first. Deadlocks usually happen when 1. Two threads hold different resources. 2. Each thread tries to access the other thread's resource. Example: class A, synchronized void method A, b.last, void last. Class B, synchronized void method B, a.last, void last. If thread 1 calls method A and thread 2 calls method B, both threads may wait forever, causing deadlock. Memory trick: deadlock is equal to two friends holding each other's books, waiting to exchange, but nobody moves. Think of it as a standstill where threads cannot proceed. Next unit 3. Long questions. First important long question is writing your own exception classes in Java. In Java, sometimes built-in exceptions are not enough to handle special cases in your program. In such situations, you can create your own exception class, called a user-defined exception. A user-defined exception is a class that extends the exception class for checked exceptions or extends runtime exception for unchecked exceptions. This allows you to throw and catch meaningful exceptions specific to your program. Steps to create a custom exception. 1. Define a class that extends exception or runtime exception. 2. Provide a constructor to pass an error message. 3. Use throw keyword to throw your exception. 4. Use try-catch block to handle your custom exception. Example: Step 1. Create custom exception class. Class myException extends exception. myException, string message. Super, message, pass message to exception class. Step 2. Use the custom exception. Public class test custom exception. Static void checkAge, int age, throws myException. If age 18, throw new myException, age must be 18 or older. Else, system.out.println, age is valid. Public static void main, string, args. Try. Check age 15, this will throw exception. Catch my exception E. System.out.println caught exception plus e.getMessage. Output. Caught exception, age must be 18 or older. Key points. Custom exceptions make your program more readable and user-friendly. Always extend exception for checked exceptions or runtime exception for unchecked exceptions. Helps in specific error handling instead of using generic exceptions. Memory trick. Think of custom exceptions as special alarms in your program. When something unusual happens, your alarm rings with a meaningful message, so you know exactly what went wrong. Next important long question is to explain the use of throw and throws with a suitable example. Throw and throws in Java. In Java, exception handling helps a program deal with unexpected errors. Two important keywords used in exception handling are throw and throws. 1. Throw keyword. The throw keyword is used to actually throw an exception. It is followed by an exception object. You can use throw to throw built-in exceptions or custom exceptions. Example. Class test throw. Static void checkAge int age. If age 18. Throw new arithmetic exception. Age must be 18 or older. Else. System.out.println age is valid. Public static void main string args. CheckAge 15 throws exception. Output. Exception in thread main java.lang.arithmetic exception. Age must be 18 or older. 2. Throws keyword. The throws keyword is used in a method declaration. It declares the exceptions that a method might throw, so the caller can handle them using try-catch. Example. Class test throws. Static void divide int a int b throws arithmetic exception. System.out.println ab. Public static void main string args. Try. Divide 10 0 might throw exception. Catch arithmetic exception e. System.out.println cannot divide by 0. Output. Cannot divide by 0. Difference at a glance. Keyword usage when. Throw throws an exception object inside method block. Throws declares exceptions a method may throw method declaration. Memory trick. Throw is equal to fire the arrow, throw the exception now. Throws is equal to warn others, method may throw exception. Next important long question is 3. Write a program for exception handling by using try-catch statement. Exception handling using try-catch in Java. In Java, errors can occur while a program is running, such as dividing by 0 or accessing invalid array indexes. To prevent the program from crashing, Java provides exception handling using try-catch blocks. Syntax. Try. Code that might throw an exception. Catch exception type E. Code to handle the exception. Try block contains code that may cause an exception. Catch block handles the exception if it occurs. Example program. Public class try-catch example. Public static void main string args. Try. int numbers is equal to 1, 2, 3. System.out.println accessing element at index 3 plus numbers 3. Catch array index out of bounds exception E. System.out.println exception caught array index is out of bounds. Try. int result is equal to 10 0 division by 0. System.out.println result plus result. Catch arithmetic exception E. System.out.println exception caught cannot divide by 0. System.out.println, program continues after exception handling. Output. Exception caught, array index is out of bounds. Exception caught, cannot divide by 0. Program continues after exception handling. Key points. Multiple try-catch blocks can be used for different exceptions. Program does not terminate when an exception occurs. The catch block receives an exception object to display details. Helps in making programs robust and user-friendly. Memory trick. Think of try-catch as a safety net. Try is equal to take the risky step. Catch is equal to catch yourself if you fall. Next important long question is 4. Write a program on throws clauses. Using throws clause in Java. In Java, the throws keyword is used in a method declaration to indicate that the method might throw an exception. This informs the caller of the method that it should handle the exception using try-catch. Throw is equal to actually throw an exception. Throws is equal to declare that a method may throw exceptions. Syntax. Return type method name, throws exception type. Code that may throw exception. Example program. Import java.io*. Public class throws example. Method declares it may throw IO exception. Static void read file throws IO exception. FileReader file is equal to new FileReader, test.txt, file may not exist. BufferedReader BR is equal to new BufferedReader file. System.out.println, first line, plus br.readline. br.close. Public static void main, string, args. Try. Read file, call method that may throw exception. Catch, IO exception E. System.out.println, exception caught, file not found or cannot be read. System.out.println, program continues after handling exception. Output, if file not found. Exception caught, file not found or cannot be read. Program continues after handling exception. Key points. 1. Throws is used in method declaration, not inside the method body. 2. Multiple exceptions can be declared using commas. 3. Void myMethod, throws IO exception, arithmetic exception. 4. Helps in cleaner code by separating exception declaration from exception handling. 5. Ensures caller knows which exceptions need to be handled. Memory trick. Think of throws as a warning sign on a method. Handle with care. This method may throw an exception. Next important long question is 5. Write a Java program to illustrate the use of thread synchronization. Thread synchronization in Java. In Java, multiple threads may access shared resources simultaneously. If two threads try to modify the same data at the same time, it can cause data inconsistency. Thread synchronization ensures that only one thread can access the resource at a time, making the program thread-safe. Why use synchronization? Prevents race conditions. Ensures data consistency. Achieved using the synchronized keyword. Example program. Class counter. int count is equal to 0. Synchronized method ensures only one thread accesses at a time. Public synchronized void increment. Count plus plus. System.out.println, thread.currentThread.getName plus count. Class myThread extends thread. Counter. MyThread counter. This .counter is equal to counter. Public void run. For int I is equal to 0, I5, I++. Counter.increment accessing synchronized method. Try. Thread.sleep 100 simulate some delay. Catch interrupted exception E. E.print stack trace. Public class thread sync example. Public static void main string args. Counter C is equal to new counter. Create two threads sharing the same counter object. MyThread T1 is equal to new MyThread C. MyThread T2 is equal to new MyThread C. T1.setName thread 1. T2.setName thread 2. T1.start. T2.start. Output thread safe example. Thread 1 count 1. Thread 2 count 2. Thread 1 count 3. Thread 2 count 4. Notice that the count increments in order. No data is lost or overwritten. Key points. 1. Use synchronized with methods or blocks to control thread access. 2. Helps to avoid race conditions. 3. Only one thread can execute a synchronized method on the same object at a time. Memory trick. Think of a synchronized method as a single-lane bridge. Only one car thread can pass at a time, preventing accidents, data inconsistency.